We'll start. So thanks for coming. People outside, you're still able to join. My name is Daniel Feldman. I manage the Communications Power BU at Microsemi. If you speak Chinese, my name is Champagne Outze, which means what Daniel Feldman means in Yiddish. So we'll go over a few Power over Ethernet standards. We'll talk about Power over HDBaseT. How is it safe? You know, I had questions, are you going to fry the cable? Is it really the same cable or a separate cable? So no, we're not going to fry the cable. And we'll look at a few applications. Some of them were covered by Miha, some of them were not, and we'll have a summary. So first of all, a little bit of Microsemi. Microsemi was founded in 1960. Our colors look like the Microsoft colors. They actually tried to sue us for copying the logo. The font is the same. Then we mentioned, guys, you're from 78, you're from 60, who should sue who? But anyway, we are incorporated in Irvine and roughly $850 million revenue. We're a fairly diversified company. We're the only company in the world that has FPGAs and analog and power and microcontrollers, FETs, diodes, and Power over Ethernet. And we make both semiconductors and complete systems. And everything that I'll describe here applies to systems that are used by installers, but we also make our own semiconductors for Power over Ethernet. We got into Power over Ethernet through the acquisition of Power Design. If you see Power Design branded Midspans, they are by Microsemi. And we have a pretty big market share in the PoE and now PoH semiconductor market. Fairly big share in Midspan market. We were in the IEEE 802.3AF, 802.3AT standardization. I personally was in the 802.3AT standardization committee, and now another Microsemi employee heads the HDBaseT technical committee. Now we shipped over 120 million PoE ports since '99 to several of these companies. Now, what is PoE? So PoE is a technology that allows delivering power over standard Ethernet cables. It is an 802.3 standard, which means 100 meters range. It's compatible with gigabit Ethernet running over Cat5 cable. And when people specified PoE, when they thought about PoE, even before there was a standard, the idea was to save costs, to remove the AC outlet, so you have higher reliability by having a single point of backup instead of having a UPS near every AC outlet. Easier deployment, no need for a certified electrician. It's more safe than using AC. If you put your fingers on the AC outlet when you're plugging, you will have an issue. With PoE, that doesn't exist. And it is a standard. There were technologies before PoE. What Power Design invented in '99 was not a standard technology. This is a standard, so you can buy equipment from any manufacturer as long as it says PoE and it's compliant with the IEEE standards, it will work. Now in PoE, there are two types of devices. There are devices that send power and there are devices that receive power. So the PSCs, the power sourcing equipment, and the power devices, or PDs. These are names that were defined in the PoE standard, and as you'll see in the later slides, PoH borrows a lot from PoE, and we still use these names PSC and PD. Now there was a question, I didn't intend to show a slide as technical as this in this presentation, but there was a question, okay, how does it work? I mean, you're sending data and power, how come, what is this? So the idea is, in PoE, and I'm showing a simple example, 100 base T. You use, in a Cat5 cable, you have data pairs and spare pairs. You send power on the external side of the transformer. So all the data is AC signals. Power is DC. Power is received. On the receiving side is extracted before the data, before the transformers. Therefore, you have 1500 volts isolation between data and power. Same concept applies to gigabit Ethernet. The same concept applies to HDBaseT. So any questions about this? Because this is a key concept. This is one of the reasons why it doesn't affect data at all. Okay. Now, what are these standards? More details about them. So the first standard was IEEE 802.3af, standard from 2003. It defines sending power over 2 pairs. What are these 2 pairs? So here you have 8 wires in a Cat5 cable. You have the data pairs and the spare pairs. So it's 1, 2, 3, 6, 4, 5, 7, 8. So you can send power either over 1, 2, 3, 6 or over 4, 5, 7, 8. This was the original 802.3af spec. And it allowed sending 15.4 watts, receiving 12.95 watts at 48 volts. Now, there is a very important thing here. This assumes things. There is an inherent assumption that you have a cable that has a certain resistance and that you will waste power on that cable. And you have to assume worst case. So you cannot say, oh, but I have a shorter cable and, you know, so I'm gonna take 14 watts on the PD. No, you can't take 14 watts because IEEE works on worst case. Then 13 watts is a nice number to get, but you can't power too many things with 13 watts. Maybe a few phones and access points and cameras, but not higher power devices. So in 2009, the IEEE came with PoE Plus, where you send 30 watts and you receive 25.5 watts. We increased the voltage. Now most devices send roughly 54 volts. Now, one of the nice things about IEEE 802.3at 2009 is that while there isn't a clear standard for sending 60 watts, and you will see different names from different manufacturers, there is the possibility of sending 60 watts without infringing the standard. And this is kind of and this is one of the things that POH fixes, because with POH there is a very, very clear standard on how to send 60 watts. Cisco calls this UPoE, and because Cisco is much bigger than Microsemi, we are going to call it UPoE for the sake of this discussion. And again, you send 60 watts, you receive 51 watts. There are devices out there in the market that comply with this. There are Zero clients from Fujitsu Siemens, from Samsung, Axis, cameras. Now, all of these, again, are based on worst case voltage, worst case current, worst case cable resistance. Now, there is one thing that you can look at this worst case. When you do 15.4 minus 12, minus 13, you're talking about 2.4 watts. Yeah, you lost 2.4 watts, not a big deal. You go from 30 to 25.5, you lost 4.5 watts. That's okay, still not a big deal. Now, when you look at 60 watts and receiving 51 watts, this worst case is 9 watts of power being dropped on that cable. I'm not sure that that's a good idea, because maybe you have a 55 watts device that you want to power, and assuming worst case is not that of a good idea when you have these higher levels of power. So, of course, POH took care of that. So let's look at what 802.3af brought to us originally. It brought us classes. We had 5 classes, or 0 to 4. Which allowed maximum power consumptions of different levels. In 802.3at, these classes were upgraded. So now classes 1, 2, and 3 are the same. Class 0 is kind of a joker class. So it can have multiple values. So people tend not to use it. They use 1, 2, 3, and 4. Class 4 is the new class that here was undefined or treated as 0, was reserved for future use. Here is the future utilization. So we're at 30 watts over 2 pairs, or 60 watts over 4 pairs. And there was the introduction, and this is still in 802.3at. This is still PoE and not POH. Type 1 and Type 2, where in 802.3at, Type 1 is old low power, and Type 2 is new high power. POH, because it's backwards compatible with PoE, uses the same nomenclature. So when we talk about Type 1 POH or Type 2 POH and Type 1 PoE, Type 2 PoE, it's the same.
What is the PSE stand for?
It's the power sourcing equipment, is the one that sends power. And the PD would be the power device. the guy who receives power. And all these values, and by the way, you can see always you have send and receive because the rest is dropped on the cable. It's a lossy transmission. All these values here are the sending values, not the receiving values. Now, the PoE standard also specifies two types of devices, endspan and midspan devices. These are devices that send power. These are PSCs. So what is the midspan? The midspan, that's the midspan in blue here, circle in blue. That's a box that is added to the network so the network can be upgraded to support PoE. Why would anyone do that? Well, if you already have an Ethernet switch or you already have a device that can't send power and you want to add power without replacing the infrastructure that you already have, this would be a good idea to add power. It doesn't need to be multi-port. It can be a one-port. Some people call it injector. So you can bundle many access points that are purchased. They can come with the injector built in, and it replaces the power supply. So you buy the device with the injector as the power supply, and if you want to use it, if you don't want, you can use a multi-port midspan, or you can use an endspan, which is a switch with built-in PoE support. Now, yes?
How many middle span equipment you can have? How many hops you can have?
One. Again, the midspan does not touch the data. There are companies, like we included, Microsemi makes extenders that will receive PoE in, terminate data, and then send PoE. So you can, for example, receive 30 watts and then send 20 watts. So we do that, but that's not a midspan. That is a repeater that is PoE powered and forwards PoE. The midspan is solely for adding power without touching the data. From the data point of view, the midspan works exactly like a patch panel.
Nothing being touched.
Exactly, does not touch the data whatsoever. Now, if you look at voice over IP installations and wireless LAN installations, the denser the installation, the more likely people are to have PoE into the switch, because if you look at a rack, midspan takes one more space in the rack. If you look at installations which are sparser, like wireless LAN, in many cases, then people tend to use midspans more than switches. Now, if you look at typical, and I know you guys deal more with video in types of installations, and we try to think about this concept towards TVs. If I'm making a commercial installation, and now we're not talking about 20, 30 watts per device, we're talking about 100 watts per device. If you try to add 100 watts times the number, like let's say you want to power 8 monitors, 8 TVs in a restaurant, for example, 8 displays in a restaurant. Now you have to add another 800 watts power supply here just for that. And now you have to dissipate that power somehow. I'm not sure that adding power inside a switch is a good idea moving forward POH. So this concept is very important, and my company making these boxes, we actually manufacture and sell these boxes. We, of course, are very happy with POH and with the higher power levels at POH. Now, so we spoke a lot about POH without describing what it is. So let's talk about POH. What is POH? POH is based and it's backwards compatible with IEEE 802.3AT PoE+. So everything that I mentioned about PoE and PoE+ applies to POH, 100%. There are improvements though. 4 pairs PSC is defined in POH. What is a 4-pair PSC? So let's go back to that slide where we have the drawing. Instead of sending power only over 1, 2, 3, 6, you would send power over 1, 2, 3, 6 and 4, 5, 7, 8 at the same time. By doing that, you use the copper that is there anyway, and you can send twice the power. So how much power? Up to 95 watts. Another advantage is with POH, and I gave hints about that, the shorter the cable, the more power you can deliver to the end device. And you see the math, you look at the math, and the math doesn't look good when you talk about 100 meters worst case Cat5 cable, you could lose a lot of power in the cable. Luckily, for commercial and even home applications, you don't always need exactly 100 meters. And if you talk about category 6 cables, or if you talk about 50 meters instead of 100 meters, then you're in a much better shape and you have much lower losses, which can be used by the devices being powered. There is another key element to POH that was not available in PoE, and that's kind of a detail of the detail. There's a mandatory physical classification, and without going into many details on how does this work, in PoE, for high power PoE, a device can be turned on without knowing how much power is available to it. So the device has to turn on in a low power mode, and then it has to communicate with the switch and then negotiate, which is kind of a problem. Imagine you have a TV and now you have to turn on the TV with 12 watts to know whether it has 90 watts available to it or it doesn't have 90 watts available to it. So it would be problematic. So with POH, the devices have to communicate and establish how much power is available before they start to try to turn on, which is an advantage. Now, POH introduces 3 new types of devices. We spoke about type 1 and type 2. If you remember from PoE, type 1 was up to 15 watts. Type 2 was up to 30 watts. With POH, we have a type 3. With type 3, we have 47.5 watts on the source. A maximum consumption of also 47.5 watts, because you remember with POH you can have short cables, and with short cables or better cables you actually can use all that power can be consumed in the power device. And a worst case power of 37.5 watts. This is type 3. Type 3 uses only 2 pairs. You can have a twin type 2, 60 watts, and this, by the way, is completely backwards compatible with 802.3at with regular PoE. With the difference that here the PD again can consume up to 60 watts. And we have twin type 3, which is really what we were looking for when we went into POH, where you have 2 times 47.5, and my math says that's 95 watts. Again, 95 watts, the TV can consume 95 watts, and in a worst case scenario, it's going to be 73 watts. Now, how worst case is this worst case scenario I'm describing? So to give you guys an idea, if you look at the standard looks at a Cat5 channel that has 2 patch panels, 2 patch cords, a horizontal cable, a connector, all of them worst case. And it talks about a cable which is worst case AWG24 Cat5. The overall resistance will be 12.5 ohms. I could not find this worst case. I tried to build this worst case. I didn't manage to build this worst case. I could not build anything more than 10 ohms. So you already got 20% better. If you go to Cat 6, you cannot build more than 7 ohms. You won't find a Cat 6 channel that has more than 7 ohms 100 meters. If you take to 50 meters, now that turns into 3.5 ohms. Wait a second, 3.5 ohms. So if it's 3.5 ohms, that's you remove 70% of the losses. So instead of taking from 95 to 73 watts, you actually are just taking 5 watts out, so you can really deliver 90 watts. So for the typical installation, which is really going to be Cat 6, and it's not going to be 100 meters, you're talking about maybe 5 watts losses. So when we say, yes, you can have 95 watts at the power device side, we actually mean it. Now, we spoke about how the power is sent, but the first question an installer will have to answer is this safe? So, first thing, we comply with UL 6950-1 SCLV. UL defines safety, and we comply with UL, so we're not trying to invent safety. We're trying just to follow the rules. We're like, there's a line, we're walking the line of safety. Ongoing operation is below 60 volts, which is the requirement for dry areas for UL. We'll talk about wet areas later. Now we also comply with UL 6950-1 inherent LPS, a limited power source, because the power in a single cable is under 100 watts. As long as you are under 100 watts, UL says you're a beautiful person. You don't need a certified electrician, with no need for anything special. Now, it's important to note that this is not the end of the story for POH. The UL LPS specification allows 240 watts with certain levels of protection. And we are evaluating what do we need to do to be able to increase from 100 watts all the way up to 240 watts. I'm not going to give more information about this here because this is under investigation, but this is to show that, so you know, I put the slide now 100 watts and then 3 years from now, oh, it was not 100 watts, it was 240. So we know what the limitations are and we are working within the limitations of UL. Now we also comply with the National Electrical Code with the NEC voltages that will protect non-PoE devices. And why non-PoE devices? What the National Electrical Code has is a test that is called the finger test. Why the finger test? Because it's like the baby that goes with the finger and tries to stick the finger into the source of power. So by the way, why did they create this? Because no baby can actually put the finger inside an AC outlet. So AC is safe because it passes the 30 volts finger test for wet location. So in a wet location, means outdoors, outside, if you put your finger in a connector, you cannot have more than 30 volts applied to you. Otherwise, it could be dangerous. For guys who are familiar with industrial applications and other things, why do they use 24 volts? Because of this rule. So how can PoE and POH pass this? Well, with PoE and POH, we're talking about smart power. So we do detection at 5 volts, we do classification at 20 volts. And we will not apply power to any device unless we recognize it is a device. Now, to recognize it as a device, you have to have an RJ45 connector, and you have to have the cable into the connector, and now you can't put the finger. You can't touch. So it's safe, it passes the National Electrical Code safety parameters. Now, this is all about people. But how about frying the cable, right? How about frying the cable? Is it safe for the equipment? So, first of all, there is the connected equipment. Before the cable, there's the equipment. So, first of all, we only apply power to devices that are PoH compatible. So, it's no problem. Structured cabling, Cat 5 and better, can be used to connect anything. So, the cabling itself, by definition, there is no parameter that talks about any restriction on the cabling. More than that, if you look at the standards related to cabling, National Electrical Code also has a standard for cabling. It has a standard per conductor. So per conductor for AWG24, we're talking about 1.5 amps. Above 1.5 amps, yes, it can burn and catch fire. But we're talking about under 0.475 amps per conductor. So we are very, very, very far away from the NEC maximum. And to be frank with you, even if we were talking about putting this ×2 or ×3, we would still be below the NEC restrictions. So there wouldn't be any safety hazard. There is a requirement, or more a guideline than a requirement, from the TIA, which talks about 10 degrees C temperature rise. And 10 degrees C temperature rise is something that was introduced into TIA specifications when people were talking about PoE+, and people defined, or someone smarter than me, went and spoke with all of their customers and decided 10 degrees C is the right number of temperature rise. Customers don't care. As long as you only have a temperature rise of 10 degrees C, you have a cable bundle, when all the power is applied, life is good. So the question is, if 10 degrees C is the right number, and you have 0.475 amps per conductor, how many cables you can have in that bundle when everybody is sending power? And the answer is, with a Cat5 bundle, 24 cables, with a Cat6 bundle, 48 cables, with a Cat7 bundle, 96 cables. By the way, if you're talking about, and this is for type 3, if you talk about type 2, up to 60 watts, then even with Cat5, you can have 100 cables in the bundle. So that's a fair amount of cables for the type of installations that, that would use POH. Now, so let's recap. So we spoke about more power, power. Why do you care? First of all, it's lower cost of installation. You don't need to add an AC outlet where it's not. For example, if we want to put a TV here, there is no AC outlet here. It's faster installation because you don't have to wait for the certified electrician. It's not just about the cost of the certified electricians. You get a bid, you want to install, the customer wants that brand new TV. Every day that TV is no longer the new model. You know, tomorrow there will be a new model of the TV. The guy wants to see it working. It's much faster than waiting for the electrician. Lower cost of energy. One of the nice things, if we go back to the picture, when you have a multi-port midspan or switch, this port here, which I didn't describe, this is a management port. You can control, you can shut down all the devices that are connected to the midspan or switch, so you can manage your power. You can, for example, if it is a restaurant and the restaurant is closed, shut everything down. Why waste power on that TV? So it really saves a lot of energy. Lower cost of maintenance. If there is an issue, if we're talking about a device that for whatever reason has to be rebooted, this is extremely useful for wireless LAN applications. This is also useful for display signage when you have a computer and it's not running and you don't know what's going on with it. First thing, Microsoft rule, reset. You don't need, you eliminate the ladder. The ladder is no longer needed. You don't need to go and climb and connect and disconnect. Remotely reset. And the nicest thing of all is that it's flexible for outdoor deployment. So there are today already in the market indoor to outdoor and outdoor to outdoor POH midspans. So this is an example of an outdoor to outdoor POH midspan. Is a twin type 2, sorry, it's a type 2 30 watts midspan that has this is an AC cable. It goes out, it's an open cable. And then you have RJ45 in and out. This is for almost complete surveillance, IP66 rated. And then you have a very beautiful picture of an outdoor TV that is now easier to deploy because you don't need to bring AC outdoor. If AC indoor is a problem, imagine AC outdoor. That's a real pain. The bottom line is that your customer gets to keep more dollars, you have a much lower cost type of installation. Now, there are more applications. We spoke about TVs. I mean, this is a list, and I'm not going to just read it. This is a list of several applications that require more power than the original AF standard. You have a little bit of applications for 30 watts, and then a bunch of applications that require 45 watts, 50 watts, 60 watts, up to 100 watts. Including 0 clients. By the way, this is a POH twin type 2 0 client in the market today. IP speakers. This could be a full-fledged speaker. Imagine you can have 100 watts speaker plus amplifier in one. That's a nice device. And even laptops eventually. Now, and here some real data, some correction. This is market data from IDC on the market size for TVs per size worldwide. And I marked in green what is powerable with POH, assuming that they are compliant with Energy Star 5.3. Now Energy Star 5.3, I have a link here, so I'm going to actually follow the link. And hopefully it's going to open fairly quickly. Here, Energy Star. There we are. That's the Energy Star televisions specification. Current specification 4.2, May 1st. Version 5.3, September 30th, 2011. In my book, that's 3 weeks from today. So if you want to buy an Energy Star TV that doesn't comply with the table that I showed, you have exactly 3 weeks to do it. Up to 50 inches. Up to 50 inches. If it's Energy Star, it's POH powerable. Now the good news is that this is not the last word on it, because there is Energy Star 6.0, and I'm not going to follow the link, please trust me. Effective fall 2012, and you can, if you get a copy of the presentation, you can follow the link and see what's in there. And oh, wait a second, everything is green. Everything is powerable by POH because it's 85 watts. Okay, so the question is, great, POH is wonderful and standard, and Micha, who spoke before me, was saying how great HDBaseT was because when the standard came out, there was already equipment out there. So with POH, it's not different. There is equipment out there that can do POH. What do you need to use? You need to use POH-ready PDs, POH splitters, and POH midspans. How does it work? You can have an HDBaseT source. A POH midspan is added in front of that source, adds power to it. Then you have a POH splitter. The data goes to the non-POH device, so an HDBaseT device that is not POH capable, and the splitter sends power to it. There are splitters today in the market that can send 60 watts, 12 volts DC and 24 volts DC. Microsemi manufactures these splitters. There are other companies that make splitters as well. And I wouldn't be surprised if the industry would have splitters that send 120 volts AC in the market soon, capable of delivering up to 95 watts. And this allows you to do deployment of any device up to 95 watts at distances of 100 meters using solely a Cat5 or better cable. So to sum it up, finally, and this is a vision that Power Design and Microsemi had since 1998. POH turned the RJ45 connector into the universal power plug. Every country uses the same power plug. It's amazing. You don't need to have any conversion. You don't need to have, the China versus Hong Kong versus RJ45 is an RJ45 and RJ45. You can get 95 watts from it. And the HDBaseT Alliance is continuing to work on enhancing POH capability, hopefully getting to very close to 240 watts delivered to devices over Cat5 cable. Any questions? Thank you. That's it.
We're looking to higher. At the moment, it's compliant if it's up to 95 watts, but you're saying that they're looking into 240 as well.
Yeah, and the reason for that is our goal is to be safe. We're going to the limit of safety. And the reason, by the way, why UL talks about 100 watts and we are saying 95 watts, and the reason for that is there is accuracy in measurement. So you have to leave for accuracy in measurement within the power source equipment. And there is accuracy in measurement of the guy who is measuring the power source equipment. So that's why you have this 5% reduction. The reason why we kept at 100 and not 240 is selling 100 is easy. It's inherent LPS. The guidelines that are used here are the same guidelines for PoE, for PoE+. They also talk about inherent LPS. So it's easy to sell, and it will be able to be enough for a vast majority of all TVs. We can power all TVs, okay? That's a pretty good market. Now, you want to power projectors. We were talking that projector is a 350 watts projector, is an old projector. There are projectors with this type of capability today. They're already in the 200 watt power level. So if you want to reach projectors, then you need more than that. If you want to do more than a TV, you want a TV that also forwards power to something else, you need more than that. If you want to do a desktop PC with higher computer power, you need more than that. So therefore, we're also looking at the extension to 240. But there we would need to be a little bit more careful and understand what is this protection. We need to make something that is powerful and low cost.
Speak of low cost, can you compare with the one cable your solution versus the two, one is the RG14, another power cable? What is the cost difference?
So let's go to the, where was it? Let's go, first of all, the AC outlet, deploying the AC outlet is $150 to call a per AC outlet. Certified electrician in the US.
Assuming it's already there. Assuming that outlet is there.
Okay. Then you have the, so let's assume the AC outlet is already there. You have the lower cost of energy. So it depends how much consumption we're talking about. So let's do some math, for example. Let's say, and here Excel is my helper. Let's say that you have a TV that is an 80 watts TV. Okay, so it's 80 watts. How many hours you normally turn it on? Instead of having 24 hours on, we're going to have it 16 hours on. So you're saving 8 hours per day. Okay, great. Now, how many days you have in the year? You have 365. 365. Great. So you are saving 80 watts times 8 hours a day times 365 a day. You are saving 233 kilowatts hour per year. Okay, now how much that is in money? Let's divide by 1,000. That's in kilowatts hour. This times 15 cents, $35 a year. That's 35, that's one TV, 1 year, you save $35. That's pretty cool. And that's just by shutting it down. That's not all. Now there's the maintenance. Now let's say that once a year, something happens with that TV. Some idiot, some channel is wrong, someone played with it, now you have to send the guy with the letter and you don't know what the problem is. How much that costs? I don't know. How much does it cost to go send the guy to go look at the TV? 150 bucks. So okay, so let's add to this 35, let's add 150 bucks.
What is the one-time investment?
Say again?
Initial investment.
Initial investment will depend. So that's a question. I mean, I don't want to, you know what? Let's do it. Let's go to CDW.com and let's look. So if you go to CDW.com, and here I'm not marketing or anything, so I'm not advertising pricing or blah, 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 blah. Here, 9501G/AC. By chance, it's a POH twin type 2, 60 watts, 1 port. So at CDW, you can find for $108 the source, 60 watts. Now you do the math, what does that mean? That's one unit end user price, CDW. It will last you for many, many, many years. So you recoup that cost very easy, and that's just one port. If you have a multi-port, then per port you're going to have a lower cost. And again, I'm not advertising anything, I'm answering a question. Okay, so HDBaseT Alliance guys. So you recoup the investment very, very, very fast.
On the receiving side, you also have to support.
Again, if you have a POH-ready device, it shouldn't cost anything more because you're saving. I mean, if you're talking about receiving power from AC or receiving power from PoE, you have the RJ45 connection there anyway. Now you can remove the AC connection. You can make a smaller, thinner device, so you can save on all sorts of. On the receiving side, if you have it integrated, it's zero difference. If you need to add an additional splitter right now, then yes, there is a cost, but that's going to go away. So right now, a 60 watt splitter is $82 retail, 60 watts. Again, so this is not for free, but once it's integrated, it's for free. And I would say that for certain types of customers, the capability of sending power and putting it in, especially when you don't need to install the AC outlet. When you don't need to install the AC outlet, you already got it, right? You got this and the other. It's a slam dunk. That's it. Any other question?
Starting October, if we buy an Energy Star 16-inch TV, then we can get one before Christmas this year?
The Christmas models for this year that are Energy Star will, as long as it's under 50 inches, you will be able to power it with POH from the power point of view. Interoperability has to be tested with, and by the way, in the product that I showed here, and I apologize for showing a specific product, this is a DC splitter. The TVs work on AC. There isn't an AC splitter today in the market. More to come. Any questions? Thank you.